My name is Nicole DeHaven, and my lab partner is Malambri. Today we're going to show you guys a lava lamp experiment. So let's get started. Our objective of the lab today is we're going to use common household liquids and items to create a lava lamp and observe the interaction between two liquids with different densities, and also observe an acid-base reaction that gives off CO2 gas. So with that being said,
so the main two solutions we have today are vegetable oil and water. And when you mix the two together, well, actually they don't mix, they are separate because vegetable oil is actually a non-polar molecule and water is polar. So they won't mix no matter how hard you try to mix them. If I spin this upside down, eventually the water, which we've colored with green dye, will go all the way back to the bottom because it's also more dense than vegetable oil. Water has a density of 1 gram per centimeters cubed, and vegetable oil has a density of 0.91 grams per centimeters cubed. So the water will always go back to the bottom, and the vegetable oil will always float on top.
So to start the experiment, I'm just going to go over some of the materials you'll need for this experiment. Obtain maybe a 350 to 500 milliliter glass container to do this experiment in. Doesn't really matter, but it just all depends on how much liquids you're going to use, the ratio to all of it. Hardware, you can use just one 250 milliliter measuring cup that you can find in a normal household. It helps that the ones that have metric units on the sides, because then you can see how much you're actually using in the experiment. And then your chemicals today we're going to be using is vegetable oil, just normal vegetable you cook with, water from the sink, nothing special, and then Alka-seltzer tablets that contain aspirin, sodium bicarbonate, and citric acid. The aspirin is going to be the spectator ion of today. It doesn't really matter in the reaction. We're only focused on citric acid and sodium bicarbonate, acid and base reacting together. And then food dye to put into the water so you can see the difference, because it's kind of hard to see clear water and vegetable oil. Safety today, we're going to basically make sure you're wearing clothes that you don't mind getting dirty or stained. Food coloring will stain your clothing if it's touched or comes in contact with your clothes, so just kind of your own judgment on that one. Alka-seltzer tablets, they definitely can cause irritation. If not dissolved in water before ingested, it can cause intestinal discomfort, and so just watch out for that. Also, vegetable oil can cause irritation of the skin if contacted for too long. Not very hazardous, but it will make your skin dry or crack it. So make sure y'all just wash your hands after you're done with the experiment to not worry about any of those things. So to start the procedure, you're going to obtain your glass container. So here we are with our approximately 350 milliliter glass container. You'll measure out about 200 milliliters of vegetable oil into your measuring cup, and you're going to pour it into the container, which we had already done. Then we obtain 75 approximately milliliters of water and pour that into also, and with food dye of 3 to 5 drops to differentiate the color. So here we are with the vegetable oil and the water. This is where we're at. And next, you're going to obtain Alka-seltzer. Here's just a normal original Alka-seltzer tablet. We had cut one piece up into 8 little pieces to make this experiment go a little smoother. What you're going to do is obtain your one tablet. You're going to drop it into your container, and you're going to watch it as it sinks through the vegetable oil into the water. And once it hits the water, that's where the reaction is going to start, because the water will dissociate the tablet. But we're going to save for that until the end when you can see the cool experiment in the dark. But I'm going to continue to explain the experiment just so y'all get that. So once you drop the tablet into the water, it's going to start to react and create a gas of carbon dioxide, which is going to cause it to bubble. And that's the reaction. And once the bubbling subsides, that's all the carbon dioxide that is produced from the reaction. And then you can just redo the reaction with the other 7 tablets if you want to continue to watch it do that. So some calculations to this experiment.
So when you have the Alka-seltzer tablet, it already contains citric acid and sodium bicarbonate, and that's what the reaction takes place. But since it's a solid, the atoms don't have the freedom to move around and interact with each other. So that's when you put the Alka-seltzer in water, it dissolves, allowing these molecules to move and interact with each other. As you can see right here, we have the chemical reaction. We have citric acid reacts with sodium bicarbonate to get citric acid, carbon dioxide, and water. And I found the molar mass of each. And I did some calculations with simple stoichiometry, and I found the limiting reactant is citric acid. Oh, I'm sorry. The limiting reactant is sodium bicarbonate with an excess of citric acid. And keep in mind, all these calculations are with 1/8 of a tab of Alka-seltzer. And through the reaction, we have 0.082 grams of sodium citrate, 0.042 grams of carbon dioxide, and 0.017 grams of water produced. And with that, we can finally do the actual experiment.
Dun, dun, dun.
Here we go.
Here we go.
With light.
With light.
For added effect.
Because now it's a real lava lamp.
So here goes.
Here we got
I'll choose the biggest one.
The biggest one, adding it.
We're dropping it. Here it goes.
And it drops into the water. And there it goes.
So as you can see, the Alka-seltzer tablet is reacting with the water, creating carbon dioxide, which makes the water float to the top. That's what all those bubbles are. And with the carbon dioxide, it's also carrying up a little bit of water, but since water is more dense than the vegetable oil, it slowly falls back down, creating the classic lava lamp effect.
Super cool. And now if we turn the lights, you can kind of see the actual water falling back to the bottom and the CO2 going up. And it continues to do that.
And there you have it.
There you have it, folks. That's our lava lamp experiment. In conclusion, basically what we wrote here is our objective and the procedure that we did and what we calculated and how we got the CO2 gas, the errors that could have gone into this experiment, human error from miscalculations, also from we could have chopped up the tablet into unequal 8 pieces, which would result in a different amount of CO2 gas than what we calculated originally. But yeah, and here is our works cited to thank the site that we got a lot of our information from. And we want to thank you for watching our experiment today and listening to us ramble on about chemistry. Okay, we're going to use all of this in the experiment. This is the fun part.
Whoa.
What? Look how fast it's going! Holy jeez!
That's a lot of CO2.
It's bubbling.
This is not your average lava lamp.
Lava lamp on steroids.
It's still going. Still going strong.
You can't even see like the two liquids mixed because it's going so fast.
Yeah. Damn, there's still a big piece down there.
Gosh. Oh look, there it's starting to settle again. Ah ha ha, there you go, look at that.
Chemistry.
Chemistry, we love it. Thanks for teaching us the love of chemistry, Miss Sanchez.
You are our best teacher ever.
Cool.